Hi everyone, I'm back with another question. So this question says, a problem is given below. Instead of trying to solve that problem, state a simpler problem and solve it instead. So the original problem says 11 people are being honored in their work in reducing pollution. In how many ways can we line up these people for a picture? So this scenario doesn't ask us to select people out of a group. So answers A and C are not correct. And then answer D says that how many ways could we line up 15 people? Well, lining up 15 people, arranging them in all the different arrangements that are possible is more difficult than 11. So the only logical answer is how we can line up 3 people for a picture. And let's take a look and see why the answer is 6. And we're going to just draw a diagram. I'm just going to list the letters. So let's say I would let letter A be person 1, and letter B be person 2, and letter C be person 3. Okay, these are the people. All right, so we could have A, B, C as a lineup, just as it is. We could begin with A and then rearrange, flip-flop, put C, then B. We could begin with B and then do A and C. We could begin with B and flip-flop the positions of people C and A. Or we could start with C, A, B. Or we could start with C and then flip B, A. And then we'll just add up the different possibilities for the lineup, and we would find that there are 6. 1, 2, 3, 4, 5, and 6. And then that's the answer to that question. There's also another question, and I'm going to take a few seconds, press pause, and then pull up that next question. This question asks one that's very similar to the one we just looked at. It asks us to find a similar problem that is simpler from the choices that are given. We are not asked to solve the original problem. The original problem is not a selection problem, rather it's an arrangement problem. Or I guess maybe your text defines it as a combination or permutation problem. So using 24 of the letters of the alphabet, how many 2-letter codes can we form if we are allowed to use the same letter more than once? So BG is different from GB. Which of the following is a simpler version of the given problem? Again, in how many ways can 24 of the letters of the alphabet be arranged is not a simpler problem. Using 3 of the letters of the alphabet, how many 2-letter codes can we form if we are not allowed to use the same letter more than once? It's not similar to the original problem because we are not allowed to use the same letter more than once, whereas in the original problem, it says that we can. So B is not an option. Using 24 of the letters of the alphabet, how many 2-letter codes can we form if we are not allowed to use the same letter more than once? Again, we can't use the same letter. So then that leaves us with D. Using 3 of the letters of the alphabet, how many 2-letter codes can we form if we are allowed to use the same letter more than once? So let's go back to our whiteboard and let's draw it out. All right, so this time my A, B, and C are going to actually be any letter of the alphabet, okay? And the alphabet. And we want 2-letter combinations, so we could have AB or AC. We could also have AA because we can use the same letter more than once. Following this same kind of train of thought, we could have BC, BA, or BB. I think you see where I'm going here. With C, we could have C, then an A. We could have C, then a B, and we could have C, C. And then when we find the total, we'll see that there are 3 squared, or 3 times 3, which means that there are 9 combinations, 9 combos. And maybe you don't want to call them combos. I'm hungry right now, so I'm thinking about a combo meal. But the answer to this question is 9. And if you have any additional questions, you all, while you're working on your homework or you run into any problems, please don't stress. Send me an email. I'll be happy to record a video. Or if you would like to meet in a Zoom room and we could have like a small group or whole group kind of live lecture, just let me know. I'll be happy to accommodate. All right. Thanks so much.